Hi, I'm Mick Moignard. I'm a custom DCC installer, and today I'm going to show you the installation of a decoder into this O-scale LSWR 700 class locomotive. So let's get started. First thing we're going to do is just check that the locomotive actually runs nicely on DC, and I can do that very quickly. I have under here an old Hammond & Morgan. I've got these two clip leads which will supply me with DC. If I turn my controller on, I can just very quickly check it by holding these against the wheels, and we'll see the locomotive runs. It runs reasonably smoothly and reasonably quietly. It doesn't have pickup on those wheels. And then taking it apart, using a little tray to put all the loose bits in to make sure we don't lose them. Take that screw out, pop out the chassis like this, and we can see there is the chassis. In many cases we then do a stall current test. I'll show you how we do this, but given that this is a max-on coreless motor, we know that the stall current of it will be quite low, but just for completeness, let's show you how I would do that. So the first thing we're going to do is just to show you how we would do a stall current test. Standard multimeter, set it to the 10 amp setting, make sure you've got the cables plugged in the right place, and then what we need to do is connect the meter in series with the locomotive. So I'm going to connect one of the clip leads from my DC power source to one of the pickups. I'm going to connect one of the leads from the meter to the other power source, and then you see that if I touch the second wire to the motor, it runs. Okay, and you can see the current draw of the thing running free, or running reasonably free, is about 0.2 of an amp. So what we'll now do is I will actually stop it turning by holding the wheels and try that again, and that shows me the motor is drawing 2.5 amps to do the when it's stalled, which means that strictly we should put a decoder into the locomotive that is capable of coping with a 2.5 amp stall currents. In real life, most decoders have some sort of motor protection, and therefore something with a lower current rating should be okay, so long as you're not running on the layouts where you're prone to getting ballast in the gears and things like that and jamming it. Okay, so the next thing we're going to do is just explore the wiring in the locomotive as a DC locomotive. First thing we'll do is look underneath the tender, and you can see that the tender has a 2-wire umbilical to the locomotive, pickups on the 4 outer wheels. This PCB is dealing with the pickups and carrying to that. And we can also notice this is the right hand rail and has the red wire attached to it. That's the standard NMRA wiring colour for the track pickups, is red on the right hand rail and black on the left hand rail. In the locomotive we can see this pigtail coming in from the tender, connected to the right hand side of this piece of PCB. We'll also note that we've got plunger pickups on the front 2 axles of the locomotive. Again, these are connected the right hand side to this side of this piece of PCB, and the left to that. The rear axle has no pickup, so the whole locomotive has 4 axle pickup, which is going to be quite simple. And the wiring in the locomotive is that all the pickups are wired together into this piece of PCB here, and that is then wired through the orange and grey wires, which are also the NMRA standard wiring colours, to the motor. So to be able to do this install, essentially what we need to do is disconnect the orange and the grey wires from this piece of PCB, connect those to the decoder, connect the decoder to this PCB, to the red and black wires from the decoder to this PCB, and attach a speaker to the decoder. So what we have here is the decoder. You can see from the shortened wires this decoder has in fact previously been used, I think in this locomotive, in a previous incarnation. It's a Zimmo MX645, it has a capacitor for a little bit of keep alive on it, it has the red and black wires which we will connect to the track, it has the orange and grey wires which we will connect to the motor. There are no lights in this locomotive, so all the lighting wires have already been cut off short and insulated, and then these 2 wires, the 2 purple wires, will connect to the speaker. And the next thing we're going to do is actually make up a speaker block and connect them to this. Okay, so the next thing we're going to do is look at some speakers. Now here are some examples of Sugar Cube speaker drivers. These are 18 by 15 speakers. They're spring contact ones where we can solder wires to the spring contacts. These are 15 by 11 speakers with soldering points. Either of those will work fine. My experience is that if you can get the larger speakers into the locomotive, then try that. So what I'm going to do in this case is use 2 of these, make up some boxes for them into a single larger box, and then we'll install them into the locomotive. So what we're going to do now is assemble these speakers with their resonance boxes and make up a block that we can then fit inside the locomotive. Here, as I said, we've got the 2 speaker drivers, we've got some laser cut box parts, and a closure plate. So what we're going to do first is we're going to, using some super glue, we're going to attach the laser cut pieces to the speakers first. So what I'm going to do is just put a little bead of super glue, a very tight thin bead of super glue all the way around here. Make sure it covers, because it's actually part of the sound seal. Little finger around there, and attach the speaker to it. Press them together so that we get a decent joint. Do the same with the other one. Again, a little bead of super glue around the edge of this laser cut part. Make sure we've got covered properly, speaker onto it, and there we go. And then the last step is, again, bead of super glue, which I need also to make sure is complete, because it's part of the sound seal, onto that plate like that. So that closes that box up, and then I need to attach the other one to the other side in the same way. Make sure the contacts line up. That's more preference than anything else, and we end up with a little box like that. And what that gives us is 2 8-ohm 1-watt speakers in a very compact space. Produce quite a lot of sound volume and good sound fidelity. And all we then need to do is wire these up to the decoder in such a way that the 2 cones move towards and away from each other like this, so that they're properly in phase. And you can see the spring contacts on here, which we'll use to do that wiring. So the next thing we're going to do is, before we actually start wiring anything together, is we're going to just make sure that we think everything can actually fit. So by holding the chassis against the locomotive and checking the mounting points for it, we can see that the motor fits in the rear half, right up quite close to the inside of the firebox backhead. So that gives us some space here that we can work with. You'll notice that the boiler itself has a soldered up plate in there, which means we can't actually get inside the boiler. But I'm confident that we will have enough space. If we were to put the speaker block here, we will have enough space to put the speaker and the decoder in this sort of arrangement and still have space for the motor in there. So that's what we're going to try and do next. Now we're going to start wiring all these pieces up. The first thing I'm going to do is I'm going to wire the 2 speakers in series with each other, which means I need a small piece of wire. Now I'm quite happy to bare thin wire with my fingernails. You don't need to bare much more than a couple of millimeters on this. And then I'm going to tin all 4 of the contacts on the speaker very quickly. 1, 2, 3, 4, and then this piece of wire, both ends of this piece of wire, which I'm going to use to connect the 2 speakers together in series. So the piece of wire will go onto one contact here, and wait for it to set, and onto the opposite contact on the other speaker. And that means that we've wired these 2 speakers positive to negative, so that means that they will be also in phase when we connect them to the decoder. So that's the 2 speakers wired together there. The next thing I'm going to do is connect the pair of them to the purple wires on the decoder, which you'll notice are previously soldered. There's a bit of a mess. They've had some shrink back on the thing, so we're just carefully re-tin those and solder them to the other contacts on the decoder. There and here. So they're all soldered. Give it a little gentle tug just to make sure that everything is together and all is good. Now we're inside a brass locomotive body, so the thing we need to make absolutely certain is that those speaker contacts can't touch anything they're not supposed to touch, particularly if it were to be live, because if we get a short circuit between the speaker and the track, or we get a short circuit between the two speaker terminals, that will be terminal for the decoder's amplifier. So what I'm going to do is I'm actually going to enclose the entire thing in a piece of heat shrink. I'm going to trim that to length. As you can see, I just hold it against it and measure it, trim it off to length, and then you're going to say, how on earth are you going to get that piece of heat shrink over that? And there is a very simple trick you can always do with heat shrink if you haven't got heat shrink that's the right size, is you can stretch it. So I have this pair of pliers which I use often for stretching heat shrink. So you can see I can pull them out gently and stretch the heat shrink to quite a marked level. Sometimes it will tear on you and you'll have to get another piece and do it again. Particularly that happens with smaller sizes, but you notice I can quite significantly enlarge this piece of heat shrink, and now I am able easily to slide it over that pair of speakers to insulate the thing. And all I use to shrink this stuff, I know you should use a hot air gun really, but I just use my soldering iron to collapse the heat shrink, make sure that the terminals inside are fully protected. It doesn't seem to affect the sound quality or the sound volume that you get from the speaker when you do this. You've noticed that the speakers are entirely enclosed. So we then have a speaker box, speakers assembled, fully insulated from the outside world, ready to go. So the next step now is to change the wiring on the locomotive to connect the decoder to the chassis and to connect the decoder to the motor. So what I'm going to do here is I'm going to remove the two motor wires from the pickups on here, unsolder them, which sometimes can be a little bit tricky because you get wires that are all over the place. Make sure the pickup wires are still firmly attached to the pickup block, and I've got the two motor wires separate. So what I do is I take the decoder and I'm going to solder the red wire from the decoder to the right hand side of the chassis there. I'm going to solder the black wire from the decoder to the other side of the chassis there, and then I'm going, with the help of a small amount of heat shrink tubing, I'm going to connect the motor to the decoder. So to connect the motor to the decoder, I'm going to need some heat shrink to cover up the joints in the wire. So I've got some heat shrink tubing here, cut off a couple of pieces, and then clean up the ends of these bits of wire so we haven't got huge great lumps of solder all over the place and massive lengths of bare wire. You really don't need more than a couple of millimeters of wire bared to make a decent joint. So what we'll do is just tidy these up, particularly this orange one. You can see that's all really rather a bit of a mess. We'll slide a piece of heat shrink onto each of these at the motor end. If you're joining dissimilar sized wires, it's often a good idea to put the heat shrink on the larger wire, and you'll notice that because of the mess that this piece of wire is in, actually sliding this piece of heat shrink down here is being a little bit of a trial, but we're getting there. You can see I can get the bare end of the wire out here, slide it down, there we go. So then we solder the decoder wires, the decoder and motor wires together. This one needs bearing again. Fingernails on this small wire works okay for me, but you might care to use a wire strip of something of this sort to be able to do that yourself. Tin the wire in the usual way. The other end is already tinned. Solder the two together, wait for it to set, give it a tug. It's a decent joint. We'll do the same with the other one. That one is tinned, That could do with a little bit of tidy up there. Connect the two wires together there, wait for it to set, and just give them a tug. Then we can slide the heat shrink over the top and off we go. Now normally you would connect the motor of a DC locomotive, you would connect the orange wire of the decoder to whichever motor wire was connected to the right hand rail, and in that way you would make sure that the locomotive runs forward when the DCC system is telling it to go forward. I've done that. If you remember when earlier on, the orange wire from the motor was connected to the right hand rail, but I haven't heat shrunk these pieces of heat shrink yet, because I'm actually going to test the installation now just to make sure that we have got it all connected the right way round and it does all work before I shrink those pieces of heat shrink. So the next thing we're going to do is that we're going to see if that bare chassis actually runs. So what I have now is the locomotive connected, this chassis connected to the program track. I've made sure that there are no bits dangling in the track, and you'll see here this connection to this piece of track is currently my program track. So before I subject the assembly to track power, you need always, using the program track, to check that you can read and write the decoder, because that tells you first of all that the decoder is correctly connected to the track, and secondly it tells that it's correctly connected to the motor. It won't tell you about any other possible sources of short circuit, but it will tell you that, and that is really important, that you should never subject a decoder to track power until you have checked that it is actually working. So on my throttle, all I'm going to do is I'm going to put this into program mode, and I'm going to try and read the address AD2 on this Digitrax throttle, and the decoder has returned the value of 3. Now I'm going to check the 4-digit address because I know the decoder is already programmed. I'm going to try reading that as well, and it comes back with the expected value 693. So all that has told me that it is actually working, and you may possibly, if you were eagle-eyed, have noticed or even heard the motor just rattling ever so slightly while the decoder is using it as a current sink to do this. So having done that, we'll come out of that. I will turn to track power, and we will try and see if it works. So I press F1, and you might be able to hear that it is in fact generating some sound. And if I set it moving, it's moving very slightly in the right direction. The reason it stopped, I think, is because all the pickups are probably a bit dirty. So having verified that everything is working as we expect, I need to heat shrink these two motor wires that I left unheat shrinked in case I needed to switch them round. We now know that it does indeed go forwards as forwards, so I can heat shrink these, make sure that those connections are all safe, and I just do this with the edge of my soldering iron. Perfectly safe to do. Make sure that they're okay. Have a quick inspection that there's nothing sticking out. Everything is looking good there. So the next thing we're going to do is put it all back together again. So what I'm going to do here is I'm going to get some double-sided tape, and I'm going to attach the decoder and the speaker to the motor in the place where I said I would. So a piece of double-sided tape, I will stick that onto the motor here. In fact, that's a little bit too big. We'll put that on the motor just there and attach the decoder to it like so, with the connections all upwards apart from the capacitor. What we'll then do is, with some more double-sided tape, we'll attach the speaker and the capacitor to the decoder. This means that the decoder is acting as a buffer between the motor magnets and the speaker magnet. It's always a good idea not to put speakers really adjacent to the motor, because of course they all work on magnetic power. So we'll attach the capacitor to the bottom of that, and you'll notice we've got a few wires dangling about which we can fold into place and just tidy up there. And the next step then is just to see if that now rather neater assembly will fit inside the locomotive. Okay, so Last thing to do is to put it all back together again. Now this is where we might have a little bit of a wriggle. In this case the chassis actually slips in underneath these, but we've still got to get these parts in. So I'm going to wriggle that all in there, then pull it all forwards a little bit, pop the chassis in underneath there and put it down there. So we've got that in. I'll recover the screw from the tray we put it in earlier, pop the screw in into there, tighten it all up, and just check visually that everything's okay. We haven't got any wires sticking out. All is looking good. So last thing we need to do is actually couple the locomotive back to its tender and give it one final track test. As you can see, we've assembled the locomotive, coupled it up to its tender on a piece of powered track. You can hear it's working. So just final check to make sure that it runs up and down. So we've done the installation, we've tested that it works, we've run it up and down. We've programmed the address, which is all the programming we've done. But of course the last thing you would always do on this now is to do things like setting the chuff rate and maybe possibly adjusting the volumes. And I'm sure you can find James Aitken's video on how to do that somewhere else on YouTube.